Why is this not? Technology doesn't like me. It does. One way to find, well, I'm going to show you what you're doing. Go to people, and then here, either graduate or undergraduate, go in, and you're allowed to choose your own team. So mine is a bit different, but you're allowed to pick your team. Did nobody do that yet? Yeah, okay. So there's like you have time to do that next week before you start, but I thought I would let you know. Okay. Before I start the class, finishing the lecture from last time and then go over the exam, so we like review. For the exam, for cheat sheet, yes. I'm recording, yes, thank you. So for the cheat sheet, sure. Yeah, I'm recording. So for your cheat sheet, you can bring one page, okay? One side. You can only bring formula, equations. You cannot have worked out, solved examples, class participation, homework, or anything. You can in English, so I will be able to read it, explain, or in Farsi if you know how to. If you want to write the procedure, for example, pre-multiply comes before post-multiply, rotation. If you explain the procedure in English, it's fine, but don't explain the solution. This times this is this, So you could bring those with you. It has to be handwritten, okay? So you cannot copy paste, because the whole idea of bringing cheat sheets, you at least one time review things, right? What's your question?
So we can't have this concept.
You can have the equations.
Yeah, but you can't have this concept.
Like sine of 30 times cosine of 30 is some like the answer? No, you cannot have that. What do you mean by?
I mean, like, have this concept.
No, as part of a solution. So if you want to be smart and explaining, if there was this problem with these numbers, you're gonna do this. Yeah, don't do that. I'm not gonna grade you. That's what I meant. So your equation can have like multiplication and everything. So equation can come as they are in the lecture or textbook, right? You can bring all the equations you want, meaning that there are variables in them. There is no worked out numbers, right? So you say, oh, I saw this robot, looks like she really likes this, I'm gonna bring that. No, you can't. So the process can be, you can bring the process, but you cannot bring the like worked out anything. Does that make sense? What kind of sketches? You can put your right hand rule like X, Y, Z, that's it. But if you put a 3-hour robot and have all the angles and axes on it and have like kind of solve it, no, you can't. The idea is I want to know how much you learn, right? So don't get smart with me. We actually check your cheat sheet. So you have to submit your cheat sheet with your exam. And if you find something that's like, oh, all right, you're gonna get 0 because you didn't listen. All right. Should be obvious. You cannot bring a calculator. You cannot use your cell phone. Everything has to be handwritten. I designed the question in a way that they are quick to solve. Right? So you will see there is a lot of zeros and ones that you say, oh, this is all multiplied by 0. So you don't actually have to multiply because it's by 0. So I'm also checking like, your thought process when you're solving something, because I timed myself and I did the solution, and I'm giving you twice the time at least. But you have to at least have done those one time, or kind of example like that. So you'll be able to just like, oh, I need to do transformation matrix, multiply them, let's do it, okay? And you cannot use your cell phones. I will give you scrap paper. You don't need those. So bring pen, pencil, eraser, smile in a good spirit and study. Study all the class participation and all the practice problem I gave you. Okay, and homeworks. Well, homeworks you did it, so you have already done it. For practice, you can check your book. There are a lot of solved examples. So go for them, put them in front of you and do it. Once you know the procedure, you can do something from top to bottom, you're good. You don't have to do 10 examples. 1 or 2 is enough if you have done it. If you have done all the homework yourself, you're good, really. You can just bring some equation and come get an A in the exam, I promise. Yeah, like exams are not hard, but they're tricky. Like I put things that I want to know if you learn something or you're just following the solution that I provided to you. Make sense? All right. Let's finish the stuff we have left from Wednesday. Why is not happening? Sharing my screen. Oh, I have to pull up the Zoom. Yeah. Sorry. Standard. Okay. So this was your 3R open chain mechanism, right? So again, when you are attacking this for the finding these numbers and angles, you go to home position, right? Especially, I think, based on your solutions, like alpha was something that some of you had problems with. And the reason is that we didn't consider that, for example, L2 at the beginning at home position is aligned with that dashed line and is aligned with X1. So X1 and X2 axes are aligned with each other. So I think that was the only part that there was a little bit of confusion about. And here, for example, X2 and X3 is the same. So if you have NR robot and all the rotation are happening in the same page, in the same plane, so you don't have any twist between the axes, right? They're all parallel to each other. So that's the part you're also thinking. You're not simply following some procedure. You're also using your critical thinking. Oh, they're all parallel, so there's no twist between them. Okay, there's no alpha I, anything. Now, AI is the distance between 2 axes, right? So if their frame are not on top of each other, there must be some distance or offset between them. All you have to do is finding in which direction with respect to your base frame, right? With this base frame, we are connecting it to our frame 1. So it rotates with our frame 1. It just makes our life easier. This one becomes 0, and then from the other ones we'll have our numbers. For theta I, none of these are prismatic, so we don't have any DI of variable, DI star. And our thetas are theta 1, theta 2 stars, like only the joint variables. Now, some of you asked and did put a end effector frame here. At this point, what is happening? So at the end of the end effector, you could do that, right? But you know that at that point, you don't have any joint, but you have a distance L3, because some of you were thinking, oh, if we put the end effector frame at joint 3, then we are not using L3. Yes, you're not, because it's not important. We are trying to track that last joint. But if you wanted to put the 4th frame, you could. Then the only thing that exists between these 2 is L3. Do you remember the slide about placing the last frame? These 2 are the same if this L3 was 0. Now L3 is not 0, so the only thing you will have is this distance. If you look, if you are going to write rotation matrix between these 2, it will be identity, right? So if you put angle here 0, when we multiply, all the sine of theta will be 0, cosine of theta is 1. It will give you identity. in your transformation. The only thing is that you will have LT. So you could do it. But usually because we are writing the joints, you're not expected to do that. But if you decide, make sure that you follow the rules, right? Again, everything should make sense. It shouldn't be you're following just procedure and not thinking what's actually happening. All right, I think most of you got this one right, so. By walking and going around class. Now this one, class participation 11. I have the solution already here. Let me copy. Well, I have to go delete that one because I'm lazy and I want to go to the exam. Delete. Go here. Someone has to steal my lap. Okay. Brad, walk with me to my car. They might be desperate. I don't know. Okay, so let's look at this. First of all, if you notice, I don't know if you notice or not, the way that the frames are assigned in this example is slightly different from what we did in our examples, right? But since I have given you the axes, you could just follow the procedure and find the solution. Now, do you remember I told you there are two methods of assigning frames? One is traditional, one is the other one. So this is that traditional frame assignment. They assign the frame on the next joint. So you see here, this is your first joint, but the frame assigned on the second joint. I'm not expecting you to follow this, but you will find a lot of example on the internet when you're trying to look for examples, you know, just for the good of studying, that they're following this. Their transformation matrix will look different from ours, okay? So just be aware. So you can use, but you have to make sure that you're following our frame assignment method. Make sense? But I wanted to show you that there's another way. But I don't think it's worth our time to discuss this one. It's just a different assignment. All right. So joint one, that's circular rotation. AI minus 1 following distance 0, Z0 and Z1. So Z0 and Z1 are in the same along the same axes. So their distance along X0 is 0. X0 is perpendicular to, right? Alpha I is also 0 because they are coincide. Now let's check DI. We never had a DI constant value, right? So what is DI? D1 here is distance between X0 and X1. So X0 X0 and X1, okay, but in what direction? Z1 direction. So this is Z1 direction. So this will be DI. Now, some of you might say this is negative DI, but we could say DI is a negative number, right? So you will assign it as a variable. Then theta is theta 1 because they don't have any they don't have any twist. There's no twist between X0 and X1, and you'll have theta 1 star. For the second one, you have prismatic joint. And so D2 here is your variable, so D2 star. And third one is also prismatic, D3 star, alpha I minus 1. So alpha 2, the alpha 1, which is 2 minus 1, is Z1, Z2 along X1. So Z1 is here. Z2 is here. And then X1 X is here. So we know that Z1 goes to Z2, but if you do that rotation from Z1 to Z2, your X will be the opposite of the current X. So this is a negative. So it's either 270, 2 pi over 3, or negative pi over 2. So 3 pi over 2, 270, or negative pi over 2, before you guys jump on me. So either one would be acceptable. Just need to show that this was a negative rotation. Okay, yes.
But X1 and X2, they don't, they're the same regardless of these two, they don't talk about different directions. And along that direction, would that not be?
So here, since I don't know if that is, I'm answering your question or not, but since that we don't have any distance given to us, assume it's 0. They're on top of each other. There's no distance between them.
Yeah, well, there's a. D2 is moving the direction of D1. I was confused on because that was how that distance between X1 and X2 along D1. So along D2, D2 is kind of like right to left. They're kind of on top. So go that direction.
So these are Z X1 and X2, right? Their origin, that's what we always check. It's both at the 0 of Z3. So this is not offset. That's why there is no offset between them, and any motion is because of the joint variable. Because this guy moves like that. So at time equal to T0, this will be here, right? This moved. Then there will be an offset, but that offset is just D2. So there was no initial offset between the two axes in Z direction. Because this is a prismatic joint, you're right, it's gonna move, right? But the motion is because of the prismatic motion. There was no previous offset between them. That's why we put D2 star.
Oh, yeah, no, I get the function.
Yeah.
It doesn't face the same direction. That's like you see D2 kind of like up and down.
Oh, okay.
Yeah.
So you could have a negative motion or positive motion, right? So if it goes in the same direction as Z, is positive, 3 centimeters. But if you see two arrows, this two-headed arrow, means that joint can move in the negative direction as well. So is that your question? I don't get this question. Can someone explain it to me?
I have the same question. Yeah.
What is the question?
I think I understand. D2 star describes the travel between X time between X1 and X2 with negative y direction, not in this direction. And it's described as a line. There's no difference between X2 and X1 along.
Yeah, these two are not offset. They're on top of each other, right?
Right. Why are you saying it should be 0 and not 0?
But P2 is your prismatic joint. It has motion up and down. You're considering that. So look at this. So offset is, I get your point now. So if these two, my hands are the prismatic joints, currently there is no offset between them, right? This is 0. Now this can go up and down. You're tracking the D2 motion for here. Now for that one, there's also no offset between this and the next because we put the frame on top of it, and any motion will be D3 only. So I understand that you think it should be 0, but this is a prismatic joint. When are we including the joint motion itself? That is your thing. When we put the DI, you're trying to find what offset they have with respect to each other. There's no offset with respect to each other, but we have to consider the motion of this going up and down. So you're saying that it should be 0, so it's 0 plus P2 star. the zero offset, but the motion of the joint is Z2. Yes.
I don't think it's more, it's like so much as a conceptual thing, because that like makes sense, right? Because I actually didn't even think about it, but I got that answer you got up here, but what you were saying makes sense in that since the DI description, like the definition of DI according to these parameters,
Mhm.
is saying that it needs to be along the Z5. So D2 would need to be along
Z1, that's what you're saying.
Well, yeah, and so like the motion is along Z1, but the description is saying it would need to be along Z2. But it wouldn't make sense for there to be any motion along Z2 when you're describing Z2.
So I think the reason this is happening is because the frame assignment is different, right? And the expression that we have and the understanding is from our own assignments. So our own assignment would be Z1 will be below Z2, and then there will be Z3. Then you will see the motion. Here we are trying in this table to show the offset if there is any twist between them. If not, just put the prismatic motion, okay? So this is because of that. And that's why when you write the transformation function and the matrix transformation T, there will be a different equation to consider this effect. Yes. Yeah, that is, yes. Yes, so there is no offset in this way, but the motion will be there. Yeah, thank you for clearing that up. So for this one, your transfer function, like, sorry, the transfer function, the T is different from what we had, and we'll consider this. You can, I think, find that T from if you look for traditional DH convention. It's a different matrix than this one. The rotation happens differently. So what I'm going to do is I'm going to go review the exam. We can come back to this and make sure it's clear. If this is not part of your exam, I think priority right now is reviewing the exam. All right, but you can always work on this one. Okay. Let me bring the correct solution up. I thought about the exam. I'm not going to change my questions. How many of you looked at the questions? Raise your hand. It's okay if you didn't. All right, good. So I'm going to post the solution. I'm going to go over the solution. Okay, I'm not going to write it down. But what you're going to do is read the question. I'll let you take a few minutes if you haven't done so. And then we talk about our approach, because the questions are going to be different, right? So there's no point for me actually going over, but you have the solution. So make sure to read this first page. You must write your names, type it like what I did, because that's the only way I know who's who. And you're also signing the fact that you're not going to look over someone's hand or use other resources during your exam other than your awesome self. Okay. I already talked about cheat sheets. You have 55 minutes. You should not need as much. I have given you values for sine, cosine that you might use or you might not use. Just provide it so you don't panic. If you have sine of a degree of an angle, you can find the cosine easily, right? So I trust that everybody knows. Square root of sine square plus cosine square is 1. So we all know that. Short question, there will be 5. These are more conceptual, or you have seen it before. So it should take you 10 minutes to do this. And the reason for 10 is 4 and 5 needs a little bit of calculation. But since you have seen it before, it should be pretty straightforward. All right. And I tried to give you some hints what they're going to be. So when you're studying, you can prioritize which part to study. Right. So like similarity matrix is not going to be there. So don't waste your time on that. Something like that. All right. There will be a degree of freedom question. Now look at this mechanism. Maybe I should bring, well, look at question 1 before looking at my solution to see if you can solve the degree of freedom. This is one of your textbook questions. So the question I picked is also in the textbook. So that's all the hint I can give you. Pretty straightforward. You have the ground, count ground once, you have to count the links, right? So be prepared to see or might not see overlapping joints, right? Overlapping link. If there is a, for example, here you see there is a prismatic joint, but this is a slider because the shape of the arrow, right? If it was a dashpot, we will have something like this. So what's the difference in prismatic between dashpot and a slider? Then we have them, what changes? So if you have dashpot, you have 2 links, right? Then you have a slider, you only have 1 link because it slides through that link. That's the only thing that you need to remember. Also, if you have overlapping joints, make sure you're counting them as many times as you need it. The equation you need to bring is what UF is, what does NJ and sigma Fi mean? I'm pretty sure everyone knows based on what we practiced, right? So if you go through that, you see that we have 5 links plus ground, 6. I like to write how many joint, what kind I have. So if you made a mistake, I can just deduct a little bit of point, maybe 1 from there and solve the rest based on your assumption. If you just write 6 and make a mistake somewhere, I don't know how did you get the 6, so you lose more points. So try to be as detailed. If you follow this procedure, it's pretty straightforward. If you make any mistake, you lose a point, and then so you get 9. Yes.
If all you put is 3.
What?
If all you put is 3. It's no work.
Oh, you get 0. Yeah, you definitely get 0. If there's no work, I don't give you any points, not even 1, because this 3 can come from anything, and there is a chance in 1, and I don't know how many chance that you'll get it right. So just putting the equation does not grant you any points. Why? Because you brought it with you. So that's the downside of bringing GQ. Equation don't get you anything. You actually have to work. Your second question is going to be something about transformation, right? From one frame to another. You have a bunch of questions. I thought this was interesting. So consider a robot arm mounted on a spacecraft shown in this picture. So this is the robot arm mounted in the spacecraft. And you have satellite and Earth. You have 4 frames. Frames are attached to the Earth, satellite, spacecraft, and robot arm. Suppose the origin frame S, she will find S is the satellite, as seen from Earth. So the origin of Earth, satellite from Earth is 1, 1, 1, and the TER means the rotation and the position, right? Is this transformation? I'm asking you to write down the coordinate of origin of frame S, satellite as seen from the robot hand, and I'm asking what does your finding tell you about the location of the arm? Those of you that solved this, what was the solution? Did anybody solve or just looked at it? Just looked at, okay. So we have PES, right? So ES, we have, what is going on today? There's a noise. We have PES 111. We are trying to find PRS. So we can write this equation. PRS is TRE PES. So we usually don't put this S when we solve the equations, but you're just saying that this E has been seen from S. So remember so we have TER to find RE, we have to get the inverse. Follow this formula, we get in TRE. When we perform this multiplication, PRS becomes 0, 0, 1, 1. So PRS is 0, 0, 0. So PRS is 0, 0. What does it mean? The origin of the satellite from the robot arm is at 0, 0, 0. What does it mean? The satellite is on top of the arm, you know, that the moment that they caught it. So if you see answers like this, don't panic. Oh my God, there must be something wrong. No, that is 0. It just means that at that point, the robot actually reached the satellite, right? So
Are there answers that we could see and be like that doesn't make sense because that would put it
through it, what do you mean? It would be a negative number somewhere, right? Because you're checking the origin of the frame on the satellite and origin of the frame on the arm. There are 2 points only. So if it passes through, if you mean, there will be a negative number somewhere. So I just didn't catch. So later on, when you have a controller, you keep checking his number. If it is 0, and then you say, okay, it's grabbed, right? So this is like partially what happens, not exactly like this, but same idea. So if you get an answer like 0, 0, 0, don't panic. It is the answer. I might ask, okay, what does this mean? So even if you got something that doesn't make sense to you, explain to me. This doesn't make sense to me. I thought it should be this. So if you made mistake somewhere, but your reasoning is correct, I was like, okay, I can give some point for your train of thought, you know, how you thought about it. So always think about your solution. Does this make sense? Okay, it's important. Third question will be something of POE. Again, I think this is one of the practice problems of your textbook. Pay attention what you've been asked. Here I'm asking, what is end effector 0 position configuration M? So this is your home position currently. So M, it's here. You see that here, theta 4, this is the positive direction. So if this goes down, it gets negative. Like in real life, if you want to go down, say go -1 in Z4 degree direction and goes down. So finding the origin of M, what is the rotation? So this is x0, y0, z0, x, b, y, b, z. Same direction, identity matrix. So you see, this is very quickly writing those down. It should take you 30 seconds, right? So those are identity, we know the zeros now. What is this position in x0 direction, right? 0. What is this position in y0 direction? L1 plus L2. What is this in z0? Z0 starts from here, so this is positive L0. And those are the points. You got your M. And then for omega I, for this, like here I'm asking for screw axes, SI. So I'm looking for S1, S2, S3, the 6x1 vector. So create that table, make sure if you have prismatic joints. If you have a revolute joint, I would suggest identify Z axis for yourself. So you know the direction of omega. And that's about it. And don't forget, let me say that. I think this was one of the points Brad mentioned. For VI is negative omega I cross QI. Don't forget the negative sign. Yes.
we have to show work for getting the M matrix.
There's
or
no
should
work.
we
I
graph
just
it?
do the same thing. Like just write M. That's your work. You don't have to tell me, oh, this is, you know, you don't have to explain anything. When you write M, what M is, that's showing your work. So that's the part that you absolutely will get it right or wrong.
I mean, in this one, it's clear because the identity matrix, but if it's like rotated at all.
You
then
just have to
show,
have
like,
those numbers correct. I don't need to
Okay.
see how you got it. So, okay, you don't have to write cosine direction for me. That's how you got that point. But by now, I expect you to know it. All right. So that is showing your work. But for screw axis, this is showing your work. This is just the final solution. And don't forget to write this. If it helps you for grading purposes, all of these numbers have a grade point to it. This is just showing me your work. So if you made a mistake here, obviously you're gonna make the same mistake here. I'm not gonna drop 2 points. Right? So if you are copying from here to go here, make a mistake, depending on how much I like you, I might take the point or not. Michael. All right, yeah. For the last one, prismatic. For which one? For 3? For this one? Okay. This is the cross product, right? Negative cross product. I tried to do it correctly. Hopefully this is correct. One way, okay, I'll explain, but if you think it's confusing, forget what I said, okay? But for checking if these make sense, look at the direction of z-axis, all right? If the z-axis goes through your base frame, there's gonna be no linear velocity because of rotation. So before doing that, even without knowing what QI is, I know V1 is gonna be 0 because frame one, the original frame 1 is going through the original frame 0. So there is no offset, remember? So VI is 0, there is no extra linear velocity. Now for this one, definitely gonna be a velocity. Now think about momentum, right? Like moment arm is that L1, you have its Z direction. So that is definitely gonna have a velocity. The third one gonna have velocity. Fourth one is just a prismatic. So you just have prismatic. So these are things that you can check, right? But you can't just use those because you might get it wrong. Yeah. So as you see, questions are gonna be same level of difficulty, I would say. But you just need to have done them at least once yourself without looking at the solution. One thing I realized in student studying is you're like all-nighter, obviously. And then you don't have enough time. So what you do is you just read the annotated lectures. Reading something does not mean you learned it. It means you understood. You know, if you learn, put only the question in front of you and like all the equation you need and solve and see where you get stuck. That's the part you need to learn. All right. So if you practice this way, first of all, you don't need 2 days. I think 1 day is enough. A few hours, but you have to study this way. So when you're writing your cheat sheet, that's the best time because you're writing the equation, you're fresh, try to solve a problem and then check the solution. If you're right, then you're good. Don't do like million questions, really. Sounds good? Awesome. Okay. Off to your lives. It's the weekend. You're good.
Quick question.
Yes.
Will we have